Today I'm going to present our paper, User Expectations and Mental Models for Communicating Emotions Through Compressive and Warm Affective Garment Actuation. I'm Dr. Brad Holschuh, representing my co-authors Dr. Esther Fu and Dr. Lucy Dunne, and we come from the University of Minnesota Wearable Technology Lab. This work builds on past research which shows that emotions can be reliably communicated through touch alone, which means if you can create a system between a sender and a receiver where touch can be communicated over distance, that provides opportunities to convey emotion. This is particularly exciting because there are new forms of actuators which can be built into wearable systems called shape memory alloys, which can produce both heat and warmth through a single actuation step, which may be a new paradigm for creating remote emotional experiences. So in particular, this study sought to try to understand the strategies that might be used to use computer-mediated compression as a way of remotely communicating emotions. So to answer these questions, we performed two online surveys. The first survey asked individuals to communicate an emotion using a hypothetical controllable compression garment. And in that garment, you could vary the location, the intensity, and the pattern of the compression that a receiver would feel. And we asked them to design experiences to communicate a variety of emotions: sadness, happiness, love, etc. And we wanted to learn from them both what parameters they would pick, and also why would they pick them if you were trying to communicate those emotions. So we collected a ton of data in survey number one, and we don't have time to go through all of it here. I would refer you to the paper. But one example of the data that we collected are association tables. What you see here are associations between emotion and a certain parameter that may be actuated on the body, the location, the intensity, or the pattern. And what these charts teach us are both the degree of intensity of association, represented by the size of the circle, and also the quality of the association. If they're blue, it means there was a positive association. If they're red, it means there was a negative association. So this allows us to learn a little bit more about strategies that a user might deploy if, for example, they are trying to communicate happiness. It tells us where, how strongly, and what pattern they would prefer to use to communicate that emotion. Survey number two specifically tried to look at whether differences in strategy could be measured if you gave different instructions to the sender. So we recruited 80 subjects and split them into a communication group and an elicitation group. The communication group was charged with communicating their emotional state to a receiver. So communicate how you feel to them. The second group, the elicitation group, was given a different charge. Their responsibility was to make the receiver feel an emotion. So you send something that makes the receiver feel a particular emotion. And the objective of the study was to see, would we notice differences in strategy depending on if you were in a communication group or an elicitation group. So like survey number one, we collected a ton of data, and we don't have time to go through all of it in this talk, but I'm going to focus specifically on two cases where we saw a significant difference between the communication group and the elicit group. And those dealt with the location as it applies to the emotion of fear, and the intensity as it applies to the emotion of happiness. First, let's look at fear. We see that the group that was trying to elicit the feeling of fear in a receiver overwhelmingly would choose to squeeze somebody at the neck, which makes sense. It would replicate the experience of being strangled, which would probably induce fear. The communication group, on the other hand, had a much wider range of possible choices for where on the body you might squeeze them if you're simply trying to communicate the idea of fear. And so what this tells us is that there may be differences in strategy if the sender is coming from a mental model of communication versus a mental model of elicitation. Similarly, we see differences in strategy when trying to communicate versus elicit happiness. For the group that's trying to communicate happiness, we see high intensity being preferred as a form of self-expression. If you are trying to elicit happiness in a receiver, on the other hand, low intensity is preferred, which appears to mimic the more gentle social touch that you might attempt if trying to make somebody else feel happy. So again, this shows us that the mental model of the sender may go a long ways toward determining what strategy they may use in communicating versus eliciting that emotion. So we learned a lot from these studies. The first being that there's a balance between providing lots of options versus too many options. And so we need to provide the autonomy for individuals to pick patterns that make sense to them without overwhelming them with too many choices. Secondly, and perhaps more importantly, we come to realize that the mental models of the sender versus the receiver are going to go a long ways towards understanding the strategies that they would use to communicate, but also the interpretability of those communications. And if the mental models are not well known and well understood, then communication might fail. So future work in this space is to actually build and deploy these garments. We can make shape memory actuated garments like you see in the bottom right, and the next step is going to be getting these in the hands of senders and receivers to attempt communication, to encode and decode an emotional communication to see to what extent can a receiver interpret accurately the intentions of the sender. I'd like to really briefly acknowledge the support that made this work possible. First, the IEEE Innovation in Haptics program, the University of Minnesota Doctoral Dissertation Fellowship Program, which supported Esther's work, who was the lead author of this paper, and additionally the University of Minnesota Grand Challenges Research Grant. Thanks, everyone.